Okay, people, next trend, electronegativity. This is a lot, I know. Stay with us. Electronegativity should be on the back of your periodic table. We defined it as an atom's desire to grab electrons from other atoms, right? How bad do they want more electrons than they currently have? So here's the trend. As we go from left to right across the periodic table, atoms are getting closer and closer to the noble gases. So our electronegativity increases. Okay, from left to right across the periodic table, electronegativity increases. Now there's a trick here. Remember, this is the tricky one. That electronegativity keeps increasing all the way through the halogens, because the halogens are very close to noble gases. They just want one more valence electron before they become stable. All of those noble gases, though, in the last group or family are already stable. They have an energy level that's completely full. They don't want to change. So the electronegativity increase stops before you get to the noble gases. They do not want to change. They have no desire to gain any more electrons from anywhere else. They're happy where they're at. Okay, so that's a tricky trend. It increases from left to right, but stops right after the halogens before you get to the noble gases. Okay, now down a group or family, the electronegativity decreases. These elements towards the top of the periodic table don't have as many electrons as these elements do down near the bottom. So they're much more important to them. They're held very closely to the nucleus. All right. So the trend is increasing as you go from left to right, decreasing as you go down a family. That means that the elements in the top right of the periodic table have the highest electronegativity, and the ones in the lower left have the lowest electronegativity. But remember, that trend does not include the noble gases who don't want to change at all.